Tina slowly, slowly. We be working all day long, the push us bunny. We ain't playing no games, Sabatavi, Gani.
Hello guys, welcome back. We are still proving identities. Remember what we said on the previous video. We said that whenever you are proving identities, you must remember your trigonometric principles, such as your basic identities, square identity, quotient identity, and also your compound angles and the double angles, and also your basic algebra, factorization, adding, subtracting, common factor. So without wasting more time, guys, let's do number one. Let's see what we have here. They are saying that if sine theta is equals to x, prove that sine 3 theta is equals to 3x plus or minus 4x cube. So remember guys, I'm given here that sine theta is equals to x. So which means whatever I'm doing here, I need to make sure that everything is in terms of sine theta so that I can be able to substitute the value of x, to substitute this x so that my answer can be in terms of x. Understand? So I'm going to take sine 3 theta equals to. So we know that guys, theta plus theta plus theta will give us 3 theta. But I don't want to add 3 angles. Remember your compound angles. Your compound angle is formed by adding 2 or subtracting 2 angles. So I'm going to make this one to be 1 angle. So I'm going to have sine 2 theta plus theta. We know that 2 theta plus theta is the same as 3 theta. So now remember your compound angle. So this one will become A and this one will become B. So I'm going to expand this will become sine 2 theta cos theta, because the compound angle of sine is sine cos and sine keeps the sign. So plus cos 2 theta times sine theta. So bear in mind guys, this is your double angle and also your double angle. So we don't I'm going to take my formula sheet and look for cos 2 theta. So cos 2 theta has 3 personalities. So I'm going to pick the one that is written in terms of sine, which is this option. So this is your sine 2 theta, which is given by this. So here guys, I'm going to have 2 sine theta cos theta, close the brackets, then multiply by this cos theta plus, then we said here I'm going to pick the one that is written in terms of sine, so which is 1 minus 2 sine squared theta times sine theta. Are we together? Okay, so we're going to open the brackets. Remember, this cos is going to affect this cos only, so it's going to be 2 sine theta times cos squared theta plus, then we open the brackets, sorry, sine theta times 1 is going to be sine theta. So sine theta times negative 2 sine squared is going to be negative 2 sine cube. Okay, so remember guys, we want everything here to be in terms of sine, so we have to change this cos squared. So cos squared is an identity, so it's going to be to change to become 1 minus sine squared theta plus sine theta minus 2 sine cube. So if I open the brackets here, it's going to be 2 sine theta times 1. You're going to get 2 sine theta. So 2 sine theta times negative sine squared theta is going to be negative 2 sine cube theta. Then we have plus sine theta minus 2 sine cube. Understand? So then we try to add the like terms. So we're gonna get 2 sine theta plus sine theta. We're gonna get 3 sine theta. So then we said minus 2 sine cube minus 2 sine cube. We're gonna get minus 4 sine cube. But we were given that sine theta is equals to x. So in place of sine, I'm going to put x. So I'm going to have 3x minus 4. Remember, this is sine theta, which sine theta times sine theta times sin theta, which is the same as x raised by 3, which is x to the power 3. So can you see that sine 3 theta now is equal to 3x minus 4x cube, which is the same like this one. So now we can conclude that sine 3 theta is equals to 3x minus 4x cube. So understand? So let's see number 2. What do we have? You can pause the video and try to attempt the question on your own. So we have this question, guys. We are given 3 cos 3 cos theta equals to 4 cos cube minus 3 cos theta. We are proving the left hand side is equal to the right hand side. So in this case, I'm going to take the left hand side, guys, which is cos 3 theta. Remember, same approach, guys. It's going to be cos 2 theta plus theta. So if I'm changing this one, remember your compound angle, this is your A and a B. So the compound angle of cos, start by saying co, which is cos. So this is going to be cos 2 theta, cos theta. Remember, cos changes the sign when you expand. So this is going to be minus sine 2 theta, sine theta. Remember, I want everything to be in terms of cos, in this case, not sine. So I'm going to pick the last one, which is 2 cos squared minus. So this one is going to change to be 2 cos squared minus 1 multiplied by this cos minus. So we don't have any option for sine 2 theta. Is going to be changed to be sine, to be 2 sine theta cos theta times by this sine. So if I open the brackets here, this is cos theta times 2 cos squared theta is going to be 2 cos cube theta. Cos theta times negative 1, so this is negative cos theta. So then I'm going to have here, because sine times 2 sine cos is going to be negative 2 sine squared theta times cos. Remember, here in this case, I want everything to be in terms of cos. So it's a must that I must change sine squared theta. So I'm going to drop this one because they're in terms of cos. Gonna drop minus. Remember, you can take this one to be in front, then open the brackets. So you can change this one. Remember your square identity, so it's going to be 1 minus cos squared theta. And then we close the brackets. So we drop again 2 cos cube theta minus cos theta. So negative 2 cos theta times 1 is going to be negative 2 cos theta. Negative times a negative, this is going to be positive. So 2 cos theta times cos squared theta is 2 cos cube theta. And then we add the like terms. So we can see that 2 cos squared, 2 cos cube plus 2 cos cube will give us 4 cos cube. So minus cos theta minus 2 cos theta is going to give us negative 3 cos theta. So then there's no way we can move. So let's go and look what we were looking for. So they say cos 3 theta is equal to this, so which is the same, and this. Now we can conclude, therefore the left hand side is equals to the right hand side. So that's number 2. Remember, guys, you can pause the video and try to attempt the question on your own. So we are doing now number 3. we are given, this is the question that we have here. Sine 4x equals to 4 sine x times cos x minus 8 sine cube times cos. So surely in this equation, I'm going to take the left hand side again. So now I'm given sine 4x. Remember, 4 is an even number. So in this case, if I want to make my life easy, because I need cos here, which means if I have cos, I need to go to compound angle. So if I say sine 2x plus 2x, 2x plus 2x is still 4. So then I'm expanding to become sine 2x, cos 2x, then sine keeps the sign. So it's going to be plus cos 2x sine 2x. Understand? So if I change this one, I have this one. If I can take out the, remember we said we must remember your basic algebra. If I take out here the common, so the common factor, you see that this one is common, and also you can see that the cos 2x is common. Also you can do it another way, alternative way. So I can take 2x, then I will left with cos 2x plus cos 2x. So can you see that this is 2x, then inside cos 2x plus cos 2x, we're gonna get 2 cos 2x. Understand? So if I multiply, this is the same as 2 sine 2x cos 2x. Understand? So guys, if I want to do this thing, I'm going to change this double angle, because this is the double angle also here. So if I'm changing it, it's going to be 2 into inside is going to be 2 sine x cos x. Then I close the brackets, and then I multiply by this cos 2x. Remember, we don't need cos 2x here. We don't need cos 2x. I have to change cos 2x. But if I change cos 2x, guys, remember we have minus here. If we have minus here, if I take this one, it won't help me because I don't have the squared here, cos squared there. If I take the option number 2, let's take option number 2 and see what we will have there. If I take 1 minus 2 sine squared x now. So this is the same as 2 times 2, which is 4 sine x cos x. Then inside here we have 1 minus 2 sine squared x. Then we open the brackets. So if I open the brackets here, good people, this is going to multiply this one and also multiply the negative 2 sine squared. So it's going to be 4, because anything multiplied by 1 remains the same. So it's going to be 4 sine x cos x. So positive times the negative is negative. 4 times 2 is going to be 8. So sine x cos x times sine squared is going to be sine cube x times cos x, which is equals to this one. So now we can conclude that the left hand side is equal to the right hand side. So understand? So let's do the next one. So the next one we have this. And this is cos raised by 4x plus sine squared x times cos squared all over 1 plus sine x equals to this. So which side you need to take to prove here? I'm going to take the left hand side. Remember guys, this is level 2 question, but it can be given as 4 marks. So here guys, I'm going to think of my common factor. So we know that this one is the same as cos squared times cos squared. So I'm going to take cos squared outside. So if I'm taking cos squared outside, I'm going to be left with cos squared again, because cos squared times cos squared is cos raised by 4, plus then we take out cos squared, then I'm going to be left with sine squared x over 1 plus sine x. Remember, this is your left hand side. We're trying to prove if it is the same as the right hand side. So what do you see inside the bracket? I see the square identity, which is equals to 1. So I'm going to have cos squared x into 1 over 1 plus sine x. Remember, whenever you are dealing with trigonometry, you must think of your algebra. So cos squared x times 1, it's cos squared x. So remember, these guys, this is your square identity. This is an identity, so which can change and written as 1 minus sine squared x over 1 plus sine x. Understand? So remember your difference of two squares here, guys, which will be changed this one to become 1 minus sine x 1 plus sine x over 1 plus sine x. Can you see now? This one will cancel this one. You are left with 1 minus sine x, which is the same as this one. So now we can conclude that the left hand side is equal to the right hand side. Understand? So you can do this one on your own. You can interact with me through WhatsApp or through email. So I'm going to do the last one with you guys. Remember, you can pause the video and try to attempt on your own. This is the last one that we are going to do. So what do we have here? I'm given sine 2 theta all over 2 sine theta plus cos 2 theta minus 1 equals to 1 plus sine theta over cos. So which side that you need to take here, guys? It's the left hand side again. So I can see this is the double angle. Because I don't have the double angle here, I must change it. This is going to be changed to be 2 sine theta cos theta over. But here, guys, on your denominator, you must be careful. You have sine theta. You cannot change sine theta, but you can change cos 2 theta, which means what the option that you are going to take here, you must take the option that is in terms of sine. So I'm going to write sine 2 theta plus, then in place of cos 2 theta, I'm going to take 1 minus 2 sine squared theta, then I close the brackets, then we have this minus 1. So now can you see that because the positive won't change anything here, so I'm going to have 2 sine theta cos theta over 2 sine theta, so plus 1 minus 2 sine squared theta minus 1. So this one is going to cancel this one. So I'm going to take out what is common. So I have 2 sine theta cos 2 theta. Can you see, guys, here that 2 sine theta here is common? So I'm going to take 2 sine theta. Then I will be having 1 minus sine theta. So this will cancel this. Now I'm left with what? With cos theta over 1 minus sine theta. Then you need to ask yourself, this is what you want? No, this is not what we want. We need to move again. So I have cos theta over 1 minus sine theta. Then you need to ask yourself, okay, what must I do now in order to achieve, in order for me to get what I want now? I have 1 plus sine theta over cos theta, right? But here I have cos theta over 1 minus sine theta. So which means I have to rationalize. So I'm going to say times 1 my plus, since it's minus, I'm going to put plus sine theta over 1 plus sine theta. Understand? Good. If I multiply this one, remember I need this on my numerator, so I'm going to keep it as it is. Guys. So I'm going to have cos theta into 1 plus sine theta over. Remember, if I multiply 1 minus sine squared theta, I mean 1 minus sine theta times 1 plus sine theta, this is the difference of two squares. So it's going to give you 1 minus sine squared theta. You can expand it aside. So this is your identity now, good people. Then we drop this cos inside 1 plus sine theta over this is your identity, which is cos squared theta. Now, so we have cos on the numerator and 1 plus sine theta. This is cos, guys, times cos. So this cos will cancel this cos. Now you are left with 1 plus sine theta over cos theta, which is what we want. This is what we want, which is 1 plus sine theta over cos theta. So now we can conclude that the left hand side is equal to the right hand side. Thank you guys for watching. If you didn't subscribe, please don't forget to subscribe. Share the link to your friends so that nabo bazokwazi ukufumana what we are doing here. Enjoy. See you next time. Keep practicing. Breathe in, breathe out. Maths is good.